The moon has been humanity's silent companion for millennia, hanging in the night sky like a luminous puzzle waiting to be solved. We've walked on its surface, mapped its craters, and even brought pieces of it back to Earth, yet it still guards secrets that defy explanation. Think about that for a moment. Despite all our technology, all our missions, there are things up there that don't make sense. Strange structures that shouldn't exist, flashes of light with no clear source, even anomalies that suggest something, or someone, might have been there long before us. These aren't just gaps in our knowledge, they're glaring questions etched into the lunar landscape, whispering that we've only scratched the surface of what the moon truly is. Picture this: you're staring up at that familiar glow, the same one our ancestors gazed upon with wonder and fear. But what if I told you that hidden in plain sight are mysteries that challenge everything we think we know? From towering spires that cast impossible shadows to geometric formations that look eerily deliberate, the moon is far more than a barren rock. It's a canvas of enigmas, each one begging us to look closer. And today we're going to do just that. We're diving deep into 25 of the most baffling lunar anomalies phenomena that scientists still can't fully explain, and that will make you question whether we've ever really had the full story. This isn't just about curiosity, it's about confronting the possibility that the moon holds clues to something bigger. Maybe it's evidence of ancient civilizations, or natural phenomena we've yet to understand. Or perhaps it's something even more extraordinary. Whatever the truth, one thing's certain: the moon isn't done surprising us, so buckle up. By the time we're done, you'll never look at that silver disk in the sky the same way again. The journey starts now. The first anomaly we need to talk about is one of the most well-documented and yet still completely unresolved mysteries of the moon: lunar transient phenomena, or LTP. Imagine looking up at the moon and seeing sudden bursts of light, unexplained glows, or even patches of the lunar surface that appear to darken for no reason. This isn't science fiction, it's something astronomers have recorded for centuries. Even more startling, NASA astronauts reported seeing these strange flashes while orbiting the moon during the Apollo missions. Take the case of Apollo 11, when Buzz Aldrin described seeing a bright glow in the crater Aristarchus, an area infamous for its unexplained activity. Centuries before that, astronomers like Sir William Herschel in the 1700s documented similar luminous events, at one point even speculating they were witnessing volcanic eruptions, except we now know the moon hasn't had active volcanoes for billions of years. So what's causing these eerie flashes? Scientists have floated plenty of theories over the years. One leading idea is outgassing, pockets of trapped gas beneath the surface suddenly releasing and reflecting sunlight. Another possibility is meteorite impacts, creating brief explosions of light when they strike. But here's the problem: many of these flashes last too long or appear in the same spots too often to fit either explanation neatly. Some locations, like Aristarchus, seem to be hotspots for LTP, flickering like a cosmic light switch with no clear pattern. Then there are the color changes. Witnesses have reported temporary reddish or bluish tints spreading across patches of the moon, something that defies simple explanations like reflected sunlight. Even today, with our advanced telescopes and lunar orbiters, we still can't predict or fully explain these phenomena. It's as if the moon itself is putting on a light show, one we're only beginning to decode. What makes LTP so fascinating isn't just the mystery of it all, but the sheer persistence of these sightings across time and cultures, from medieval monks recording flaming stars on the moon's surface to modern astronomers capturing unexplained glows. This isn't just random noise. It's a genuine enigma, one that suggests our understanding of the moon's geology, or even its hidden activity, might be missing something crucial. And until we figure it out, those flashes will keep reminding us that the moon has secrets it's not ready to give up. Moving from mysterious lights to undeniable structures, the next anomaly takes us into even more controversial territory. On the Moon's surface, amidst the endless sea of craters and dust, stand formations that look anything but natural, like the so-called shard and tower, two of the most hotly debated features ever photographed. These towering spires, captured by Apollo missions and later by lunar orbiters, rise defiantly against the barren landscape, their angular shapes and stark shadows suggesting something far more deliberate than random geology. Take the shard, for example. This colossal spike, estimated to be over a mile high, juts out near the Euclid crater with a precision that seems almost architectural. Its smooth sides and sharp edges mirror the kind of structures we might build on Earth, except this isn't Earth, and nothing in our understanding of lunar geology accounts for such a formation. Then there's the tower, a massive cylindrical pillar photographed near the Mare Crisium basin, casting a shadow so long and uniform that it defies explanations like eroded rock or trickery of light. Independent researchers analyzing these images point out the structure's alignment, their unnatural symmetry, and the way they stand in stark contrast to the surrounding terrain. Skeptics, of course, cry pareidolia, the human tendency to see familiar shapes in random patterns. NASA has largely dismissed these formations as optical illusions or the result of low-resolution images magnifying odd rock formations. But here's where things get interesting. When civilian astronomers and digital imaging experts enhance these photos, they reveal details that challenge the official narrative. The shard's layered appearance, for instance, resembles stacked segments rather than fractured bedrock. The tower's base shows what some argue are geometric supports, almost like the girders of a skyscraper. Even the angles of sunlight hitting these structures don't behave the way they would on typical lunar boulders. The debate isn't just about pixels or shadows, it's about what we're willing to accept as possible. If these were merely tricks of light, why do they appear in multiple missions photos, taken from different angles and lighting conditions? Why do independent analysts, some with decades of experience in geology and engineering, insist these features warrant closer scrutiny? And most hauntingly, if they aren't natural, who or what could have put them there? For now, the shard and the tower remain enigmas, their origins tucked somewhere between scientific skepticism and the tantalizing possibility that we're not the first to leave marks on the Moon. Until a rover rolls up to these sites and settles the debate, they'll stand as silent sentinels, daring us to question just how well we really know our closest celestial neighbor. The Blair Cuspids stand as one of the Moon's most perplexing architectural oddities, if architectural is even the right word. Nestled within the rugged terrain of Blair Crater, these towering spires resemble a cluster of jagged needles thrust upward from the lunar surface, their sharp silhouettes cutting against the stark blackness of space. Photographed during the lunar orbiter missions in the 1960s, the images revealed not just one or two odd formations, but an entire grouping of slender, uniform structures, some stretching nearly 200 feet high. What makes them so unsettling isn't just their height, it's their eerie alignment. Standing in near-perfect rows like the teeth of a colossal comb, geologists initially scrambled to explain them as volcanic remnants, suggesting these could be hardened lava spires left behind by ancient eruptions. But the Moon's volcanic activity ceased billions of years ago, and nothing in our understanding of lava behavior accounts for such precise, clustered formations. Lava typically cools into chaotic, uneven shapes, not rows of near-identical spires. Then there's the question of erosion. The Moon lacks wind or water, the forces that sculpt Earth's landscapes over time, so how could these structures remain so sharply defined after eons of meteorite bombardment and temperature extremes? Enter the theorists who see something far more deliberate. When enhanced images of the Cuspids were analyzed, their angular edges and geometric spacing raised eyebrows. Some researchers pointed out that the spacing between the spires follows a repeating pattern, almost as if they were placed or built with intentional design. Others noted how their shadows fall at uniform angles, suggesting a structural symmetry rarely found in nature. Even their reflective properties differ from the surrounding rock, catching sunlight in ways that make them stand out like beacons against the dull lunar regolith. Skeptics argue pareidolia again, insisting the human brain is wired to impose order on randomness, but the more you examine the data, the harder it becomes to dismiss. If these were mere rocks, why don't they resemble any other known lunar formations? Why do they cluster in one distinct area, unlike the scattered debris left by impacts? And why, decades later, has no official mission revisited Blair Crater to settle the debate once and for all? The Blair Cuspids linger in that hazy space between geological fluke and something far more provocative. They challenge our assumptions about what's possible in a place we thought we understood, a reminder that the moon, for all its silent emptiness, might still hold blueprints to mysteries we've only begun to decipher. Until we land beside them, drill into their bases, or map them with modern sensors, they'll remain one of the moon's most tantalizing riddles, a silent forest of stone, waiting for someone to ask the right questions. Among the moon's many oddities, few are as visually striking or as hotly contested as the so-called Lunar Bridge, first spotted in the 1950s by astronomer Dr. Hugh Percy Wilkins. This bizarre formation arches high above the surface near the Mare Crisium Basin, spanning what appears to be a yawning chasm with impossible precision. At first glance, it looks like something straight out of a fantasy novel, a smooth, curved structure connecting two plateaus, its shadow revealing an archway that seems deliberately engineered. But here's the catch: natural bridges like this simply don't form on the moon. On Earth, such formations are carved over millennia by wind and water, forces that don't exist in the moon's airless, static environment. Even the most ardent skeptics admit the lunar bridge defies conventional geology. Some have argued it could be the remnants of an ancient lava tube, collapsed and preserved in just the right way to create the illusion of a bridge. But lava tubes typically leave behind chaotic, uneven formations, not symmetrical arcs with clean, sweeping curves. Others suggest it's a trick of light and shadow, a fleeting alignment of rocks that just happens to resemble a bridge when viewed from Earth. Yet high-resolution scans and later lunar imagery show the structure persists across different lighting conditions, even as the moon's terminator. The line between day and night shifts dramatically. Then there's the matter of scale. Estimates place the bridge's height at over 1,000 feet, taller than the Eiffel Tower. If this were just a random rock formation, the odds of it maintaining such a perfect arch over such a vast distance are astronomically low. Even more puzzling, the supports beneath the arch, which appear unnaturally straight, almost like the pillars of a suspension bridge. Civil engineers who have analyzed the images note that the angles and load distribution resemble deliberate design principles, features not found in natural lunar geology. Of course, the most tantalizing question remains: if this isn't natural, what could have created it? Ancient lunar civilizations, extraterrestrial visitors, or some bizarre, yet to be understood geological process? The debate rages on, but one thing's certain: the lunar bridge stands as a monument to the moon's enduring mysteries. Until we send a mission to inspect it up close, it'll remain one of the most compelling arguments that our satellite might still be hiding secrets we've barely begun to uncover. Deep within the jagged expanse of Tycho Crater, one of the moon's most prominent landmarks, lies an anomaly that has fueled speculation for decades. A structure so geometrically precise, it's been dubbed the Tycho Pyramid. Captured in orbital imagery, this angular formation juts from the lunar surface with a symmetry that mirrors the Great Pyramids of Egypt, its sharp edges and flat faces standing in stark contrast to the chaotic terrain around it. What makes this feature so unsettling isn't just its shape, it's the uncanny precision. The angles appear calculated, the sides unnervingly smooth, as if carved by something far more deliberate than cosmic chance. Geologists have struggled to reconcile the pyramid with known lunar processes. Most crater formations are the result of violent impacts, scattering debris in irregular, asymmetrical patterns. Yet the Tycho pyramid's clean geometry defies this expectation, resembling a structure rather than a random cluster of debris. Some researchers propose it could be an unusually preserved remnant of ejecta material blasted outward during the crater's formation that somehow settled into this improbable configuration. But even this explanation strains credibility. On Earth, such perfect triangular formations require erosion by wind or water, forces absent on the Moon. And while volcanic activity can create basaltic columns, nothing in the Moon's geologic history accounts for a freestanding, four-sided pyramid. The comparisons to Earth's ancient monuments are impossible to ignore. The pyramid's base aligns with cardinal directions much like the pyramids of Giza, sparking theories about shared architectural principles, or even shared architects. Could this be evidence of some long-lost civilization that spanned worlds, or perhaps a natural phenomenon mimicking design in a way we've yet to understand? Skeptics argue pareidolia again, pointing to low-resolution images that might exaggerate the structure's regularity, yet independent analysts using modern enhancement tools insist the angles hold up under scrutiny, with edges measuring close to 60 degrees, a common feature in engineered pyramids. Then there's the shadow test. When sunlight hits the Tycho pyramid, the resulting shadow behaves unlike those cast by typical lunar boulders. Instead of a fragmented, uneven outline, it projects a crisp geometric silhouette, further suggesting surfaces too flat and uniform to be natural. Even more intriguing, similar pyramidal structures have been spotted elsewhere on the Moon, clustering in regions with no obvious geologic links. If this were just a trick of light, why do these patterns repeat? The Tycho pyramid forces us to confront uncomfortable questions about what we're seeing and what we might be missing. Is it a fluke of nature, a monument to something beyond our history, or a signpost left by forces we don't yet comprehend? Until a rover or human crew examines it up close, the pyramid will remain a silent enigma, perched on the Moon's surface like a riddle waiting to be solved. And with every unanswered question, it whispers the same haunting possibility: maybe we're not the first to look up at the sky and wonder. The far side of the Moon has always been a vault of secrets, shielded from Earth's prying eyes until China's Yutu-2 rover rolled into view and stumbled upon something utterly bizarre. Nestled along the jagged horizon of the von Karman crater, the rover's cameras captured an object so geometrically perfect, it sent shockwaves through the scientific community: a cube. Not a rough, weathered boulder, not a trick of shadows, but a near-perfect rectangular prism perched on the lunar surface like a monolith waiting to be decoded. At first glance, the images seemed almost too surreal to believe. The cube's sharp edges and flat faces stood in stark contrast to the Moon's chaotic terrain, defying the randomness of natural erosion. Even more puzzling was its placement perched atop a small rise, as if deliberately positioned. Initial speculation spiraled. Was this some relic of ancient lunar activity, a bizarre crystalline formation, or something far more unsettling? The Chinese Space Agency dubbed it the Mystery Hut, a tongue-in-cheek label that did little to quell the frenzy. Scientists scrambled for explanations. Some proposed it could be a large, fractured boulder with unusually clean break lines, a result of thermal stress or meteorite impacts over eons. Others floated the idea of volcanic ejected chunks of solidified magma that fractured into geometric shapes. But here's the catch: natural processes on the Moon rarely produce such precise angles. Without wind or water to sculpt surfaces, most lunar rocks are irregular, their edges blunted by eons of micrometeorite bombardment. The cube's crisp silhouette, visible even in low-resolution images, suggested something different. Then came the closer look. Months later, Yutu-2 finally reached the cube only to reveal it wasn't a cube at all. Up close, it resolved into a more mundane, albeit still strange formation, a irregular rock cluster resembling a rabbit's head, with smaller debris scattered around it. Yet the disappointment was short-lived. The so-called rabbit rock raised new questions. Why had it appeared so geometric from a distance? Could atmospheric distortion or camera artifacts have played a role? Or was there something about the moon's stark lighting that transformed ordinary objects into uncanny illusions? The cube's fleeting moment in the spotlight underscored a deeper truth. The moon constantly toys with our perceptions. It's a place where shadows stretch like ink, where angles deceive, and where even the most advanced technology can't always separate signal from noise. But beyond the letdown of the rabbit rock lies a more tantalizing idea. If a simple cluster of boulders could ignite such fervent speculation, what other illusions, or genuine anomalies, might lurk just beyond the next ridge? The far side of the moon remains a realm of shadows and secrets, and the cube, real or imagined, is a reminder that sometimes the most compelling mysteries aren't about what we find, but what we're primed to see. Among the moon's most hypnotic mysteries are the lunar swirls, ethereal, brushstroke-like patterns glowing brighter than the surrounding terrain, as if some cosmic hand painted them across the surface. Take Reiner Gamma, the most famous of these enigmas, a sprawling, luminous spiral stretching over 40 miles, its delicate loops and whorls standing stark against the dark basalt plains. At first glance, they resemble the aftermath of a celestial artist's flourish, but their beauty belies a scientific puzzle that stumped researchers for decades. Here's the strangest part: these swirls aren't just superficial stains. They're magnetically charged, defying everything we know about the moon's feeble magnetic field. Conventional logic says the moon shouldn't have localized magnetic anomalies strong enough to create such patterns. Unlike Earth, with its robust global magnetosphere, the moon's magnetic field is patchy and weak, a relic of ancient geologic activity. Yet when probes like NASA Lunar Prospector mapped these regions, they detected magnetic fields 10 times stronger than anywhere else on the lunar surface. Even weirder, the bright swirls align perfectly with these magnetic hotspots, as if the two phenomena are locked in some invisible dance. So what's causing them? One leading theory points to solar wind, the endless stream of charged particles blasting from the sun. Normally, this wind darkens the moon's surface over time, but where strong magnetic fields deflect these particles, the terrain stays strangely pristine. Think of it like a cosmic umbrella, shielding patches of ground from the weathering that darkens the rest of the moon. But here's the catch: while this explains the swirls' brightness, it doesn't account for their intricate shapes. Magnetic fields don't naturally form into perfect spirals or loops. Some researchers speculate that comet impacts could be the missing link, with their explosive forces scattering magnetized material in swirling patterns. Others propose underground lava tubes, long since cooled, might channel magnetic minerals into bizarre surface expressions. Then there's the wild card: transient magnetic fields. Some scientists argue these swirls could be the fingerprints of ancient, short-lived magnetic dynamos of volcanic events that briefly supercharged the moon's magnetism before fizzling out. If true, the swirls would be geologic fossils, preserving moments of lunar violence frozen in time, but even this doesn't fully explain why they're so organized. Nature rarely creates such deliberate-looking patterns without a nudge from something we're not yet seeing. The lunar swirls are more than just pretty anomalies, they're clues to the moon's hidden history. Each twist and curve might encode secrets about its volcanic past, its magnetic quirks, or even processes we haven't discovered yet. And until we land a rover in the heart of Reiner Gamma or drill into its radiant soil, these ghostly brushstrokes will keep taunting us, a reminder that even in the stark, airless silence of the moon, there's artistry we can't yet decipher. Buried in the desolate plains of Mare Crisium lies one of the moon's most unsettling formations, a towering slab of rock so unnervingly rectangular, it's been called the monolith. This sheer-faced structure, rising like a skyscraper from the lunar wasteland, looks less like a product of nature and more like something deliberately placed. The parallels to Arthur C. Clarke's iconic 2001, A Space Odyssey monolith are impossible to ignore, but this isn't science fiction. It's a real, photographed anomaly that sparked whispers among astronauts and heated debates among researchers. The monolith first caught attention in images from NASA, a lunar reconnaissance orbiter, its sharp angles and flat surfaces standing in stark defiance of the Moon's typically chaotic terrain. Estimates suggest it towers nearly 5 stories high, with sides so precise they appear machined. What makes it even more intriguing are the shadows it casts, clean, geometric lines that don't match the ragged silhouettes of ordinary lunar boulders. Even seasoned geologists struggle to explain how natural processes could sculpt such a flawless shape. Unlike Earth, where wind and water carve arches or pinnacles over millennia, the Moon has no erosive forces to account for this kind of symmetry. Rumors from the Apollo era only deepen the mystery. Some insiders claim astronauts privately reported seeing unnatural structures during orbital passes, though official records remain silent. One persistent story involves an unnamed crew member allegedly describing a building-like thing near Mercurium, a comment swiftly walked back by NASA. Whether these accounts hold weight or not, they add a layer of intrigue to the monolith's enigma. Then there's the challenge of perspective. Skeptics argue the structure's artificial appearance is just a trick of lighting or pixelation, a common issue with orbital imagery. But when independent researchers digitally enhance the photos, the monolith's edges held up under scrutiny, revealing contours too straight to dismiss as random geology. Others propose it could be an exposed bedrock formation, though nothing in lunar science explains how bedrock would fracture into such a perfect, isolated rectangle. The most tantalizing theory, that it's a remnant of lunar volcanism, a rare, hardened lava formation that somehow cooled into this improbable shape, yet even this feels like a stretch. Lava typically forms jagged tubes or splattered domes, not freestanding monoliths with near 90-degree angles, and if it were volcanic, why does it stand alone, with no similar formations nearby? The monolith of Mercurium lingers as a riddle wrapped in shadow. It challenges our assumptions about the Moon's geologic history and, just maybe, hints at something beyond it. Whether a quirk of nature or something far more deliberate, one thing's certain: until we touch its surface, measure its composition, or see it up close, it'll remain a silent sentinel, daring us to question what else might be hiding in plain sight. Aristarchus crater has long been the stage for one of the Moon's most persistent light shows, a spectacle of flickers, glows, and darting illuminations that defy easy explanation. As far back as 1787, astronomer Sir William Herschel documented bizarre, luminous spots dancing across this region, speculating they might be signs of lunar volcanoes. Fast forward to the Apollo era, and astronauts orbiting the Moon reported similar phenomena. During Apollo 11, Buzz Aldrin radioed Houston to describe a bright glow emanating from Aristarchus, visible even in the pitch-black void of lunar night. These weren't isolated incidents. Over the centuries, hundreds of independent observers, both amateur stargazers and seasoned scientists, have catalogued unexplained flashes in this same crater, some lasting minutes, others vanishing in seconds. So what's behind these erratic lights? The leading scientific theory points to radon gas. The Moon's surface occasionally vents radioactive gases trapped beneath its crust, and when these pockets burst into sunlight, they could theoretically create brief, glowing eruptions. Lunar probes have indeed detected elevated radon levels around Aristarchus, lending credibility to the idea, but here's the catch: many reported lights don't behave like gas discharges. Some move laterally, skittering across the crater floor as if guided by an unseen force. Others pulse rhythmically, fading in and out like a cosmic beacon. Radon might explain a flicker, not a choreographed light show, Then there's the meteorite argument. The moon, lacking an atmosphere, is constantly bombarded by space debris, and these impacts can create fleeting flashes. Yet again, the timing doesn't always add up. Aristarchus's lights often reappear in the same locations, something statistically improbable for random strikes. Even stranger, some 19th century observers described geometric patterns of light clusters that formed triangles or lines, as if signaling. These accounts were dismissed as optical illusions at the time, but modern digital analysis of historical sketches reveals startling consistency in the arrangements. Could something more profound be at work? A handful of researchers point to triboluminescence, a phenomenon where certain crystals emit light when fractured. The moon's crust, stressed by tidal forces from Earth, might generate electrical charges that illuminate the surface in unpredictable ways. Others, venturing into speculative territory, suggest the crater's infamous luminosity might hint at subsurface activity we've yet to map, perhaps even remnants of ancient technology, though that's a fringe view with little empirical support. What makes Aristarchus so compelling isn't just the mystery of the lights themselves, but their stubborn refusal to fit neatly into any single box. They're not just scientific curiosities, they're a cosmic Rorschach test, reflecting back whatever framework we try to impose. Until we land a rover inside that crater, or catch these lights on high-definition cameras from lunar orbit, Aristarchus will keep its secrets a flickering enigma that reminds us how much we still don't understand about the silent world overhead. And every time another flash ignites in its depths, it whispers the same tantalizing question: what if we're not just watching natural phenomena, but something far more deliberate? Scattered like gleaming half-spheres across the moon's barren surface, the lunar domes stand as some of its most visually arresting and perplexing features. These smooth, rounded protrusions, some spanning miles in diameter, rise with an elegance that seems almost sculpted, their curves too perfect, their symmetry too precise for the chaotic landscape around them. Unlike the jagged peaks and rubble-strewn plains that dominate the moon, these domes look polished, as if shaped by an unseen hand, and that's exactly what makes them so controversial. Are they remnants of ancient volcanic activity, frozen in time, or could they be something far more unsettling, evidence of design in a place we've always assumed was untouched by anything but chance? Take the Gruithuisen domes, perhaps the most famous of these anomalies. Nestled near the crater Gruithuisen, these formations defy conventional volcanic explanations. Most lunar domes are thought to be shield volcanoes, broad, gently sloping mounds formed by runny lava flows, but the Gruithuisen domes are different. Their steep sides and distinct, almost bubbled appearance resemble silica-rich volcanoes like Earth's Mount St. Helens, a composition that shouldn't exist on the moon. The moon's volcanic history is dominated by basaltic lava, thin and fast-flowing, not the thick, viscous stuff that builds such steep domes. So how did these structures form? Some researchers speculate they're the result of rare, explosive eruptions, a type of volcanism once considered impossible on the moon. Others propose they're leftover magma plugs, chunks of molten rock that solidified in vents before they could fully erupt. But then there's the scale. Many of these domes cluster in suspiciously regular patterns, their spacing and alignment hinting at something beyond random geologic processes. In the Marius Hills region, over 50 domes dot the landscape, some arranged in near-perfect arcs or clusters. Statistical analysis suggests the odds of such orderly distribution occurring naturally are vanishingly slim. Even stranger, some domes reflect sunlight differently than their surroundings, as if made of distinct material. Spectroscopic studies reveal patches of unusually high silica content, a mineral more commonly associated with continental crusts than lunar basins. This is where the theories take a speculative turn. A handful of scientists, often working outside the mainstream, point to the dome's uncanny resemblance to artificial structures. Their uniform curvature, their clustered placements, Even their reflective properties mirror what we might expect from large-scale lunar installations, perhaps designed to harness solar energy or regulate subsurface temperatures. Of course, without physical samples, these ideas remain in the realm of conjecture, but the very fact that such arguments persist underscores how little we truly understand these formations. The lunar domes challenge us to rethink not just the moon's geologic history, but the boundaries of what we consider natural. Every time a rover or orbiter captures new images of these enigmatic mounds, they seem to whisper the same tantalizing question: in a universe of infinite possibilities, how sure can we really be that we're alone, or that we're the first to leave marks on the moon? Until we drill into their cores or map their interiors, the domes will remain silent sentinels, their smooth surfaces hiding answers that could rewrite everything we think we know. Even the most meticulously documented moments of space history hold their own peculiar mysteries, and few are as baffling as the lost thermal footage from Apollo 11. During the mission, infrared cameras captured something extraordinary: unexplained heat signatures emanating from a crater near the landing site, glowing like ghostly fingerprints in the lunar cold. But here's where the story twists. That footage, once archived by NASA, allegedly vanished or was perhaps never released to the public. Whispers of a cover-up spread, fueled by technicians who claimed the thermal data showed anomalies inconsistent with natural temperature fluctuations. So what really happened, and why does this decades-old discrepancy still matter? The controversy centers on the crater known as Moltke, a modest depression near the Sea of Tranquility. As the lunar module descended, its infrared sensors picked up strange warmth radiating from Moltke's depths, heat that shouldn't exist in a place where temperatures swing between blistering daylight highs and cryogenic nighttime lows. Normally, the moon's surface cools rapidly once sunlight fades, with no atmosphere to trap heat, yet these readings suggested pockets of residual warmth, as if something beneath the crater was generating or retaining energy. Engineers initially brushed it off as sensor noise or reflected heat from the spacecraft, but the signatures persisted even after accounting for those variables. Then there's the tape itself, or rather, its absence. Conspiracy theorists insist NASA deliberately suppressed the data, pointing to a 1969 memo that referenced thermal anomalies requiring further analysis. Skeptics counter that the footage was simply misplaced in the era of analog storage, a victim of poor record-keeping rather than malice, but the intrigue deepens when you consider similar anomalies in later missions. Apollo 14's instruments also detected unexplained heat near Fra Mauro, and orbiters like LRO have since spotted craters with bizarre thermal retention. Could these be clues to something hidden beneath the lunar surface? Scientists have floated theories, none of them entirely satisfying. One suggests that certain minerals, like ilmenite, might absorb and slowly re-radiate solar heat, creating localized warm spots. Another proposes cold traps, shadowed regions where volatile compounds like water ice could subtly alter thermal properties, but neither fully explains the intensity or distribution of the heat Apollo 11 recorded. There's also the fringe hypothesis, underground geothermal activity, long assumed impossible on a geologically dead world. Recent studies hint at residual magma pockets or tidal friction from Earth's gravity, but these are speculative at best. The lost tape anomaly lingers like a phantom, equal parts frustration and fascination. It's a reminder that even our greatest achievements in space are shadowed by unanswered questions, and that the moon, for all its stillness, might still be hiding fires we've only glimpsed in the dark. Until those thermal readings resurface or new missions revisit the mystery, we're left with a tantalizing void where data should be, and the quiet suspicion that some truths are still orbiting just out of reach. During the Apollo 16 mission, as the lunar module Orion orbited the moon, the crew's camera captured something that would ignite debate for decades: a sleek, disc-shaped object hovering near the lunar surface. The footage officially archived by NASA shows the object moving with uncanny smoothness, its metallic sheen reflecting sunlight in a way that defies the jagged, irregular shapes of ordinary lunar debris. At first glance, it looks like something straight out of a science fiction film, a perfect, flattened disk maintaining a steady trajectory as the camera tracks its path. But the real mystery lies in how authorities explained it away. NASA official stance: a lens flare caused by sunlight bouncing off the spacecraft's components. Here's why that explanation raises eyebrows. Lens flares typically appear as bursts of light, often with telltale hexagonal patterns matching the camera's aperture. This object, however, maintains a solid, defined shape, a crisp oval with clear edges even as the camera angle shifts. UFO researchers point out that lens flares don't move independently of the camera's orientation, yet this disk seems to navigate behind lunar terrain, disappearing and reappearing as if governed by its own trajectory. Even more compelling, the object's movement coincides with the astronauts' own startled reactions. In the audio recording, one crew member can be heard exclaiming, "Look at that thing." A comment notably absent from NASA public transcripts at the time. Skeptics argue that the human eye and camera lenses can play tricks in the stark, high-contrast environment of space. They cite instances where bolts, detached insulation, or even ice particles have been mistaken for unidentified craft, but this particular object behaves unlike typical debris. It doesn't tumble or drift aimlessly, it glides. Analysts who have enhanced the footage note subtle details, like a faint but consistent shadow on the lunar surface beneath the object, something a lens flare wouldn't cast. Others highlight the disk's apparent acceleration, a detail that clashes with the predictable physics of floating debris and microgravity. The debate takes a sharper turn when you consider similar sightings across other missions. Apollo 12's crew reported seeing a bright flash tracking their spacecraft, while Soviet lunar probes captured unidentified objects in lunar orbit. Could these all be coincidences, or is there a pattern we're refusing to acknowledge? NASA transparency with raw footage has been both praised and criticized. While they've declassified thousands of hours of material, some frames remain conspicuously absent or heavily filtered. What makes the Apollo 16 footage so haunting isn't just the object itself, but the questions it leaves unanswered. If this was a lens flare, why hasn't NASA reproduced the phenomenon under controlled conditions to silence skeptics? If it was debris, why does its movement defy the laws of orbital mechanics? And if by some wild chance it was something else entirely, what does that say about the moon's role as a silent witness to mysteries we've barely begun to confront? Until we get conclusive answers, that grainy, decades-old footage will keep taunting us, a flickering enigma suspended between skepticism and the unsettling possibility that we're not alone in the cosmos. Stretching like ghostly veins beneath the moon's surface, the so-called glass tunnels are among the most visually arresting and hotly debated anomalies ever photographed. These translucent tube-like structures, some spanning miles in length, appear to snake beneath the lunar regolith, their smooth, curved walls catching sunlight in ways that make them gleam like strands of molten crystal. First spotted in orbital imagery, the tunnels defy easy classification. Are they remnants of ancient lava flows, frozen in time, or could their uncanny regularity hint at something far more deliberate? The mainstream explanation leans toward volcanism. On Earth, similar formations called lava tubes occur when molten rock carves channels underground, leaving behind hollow tunnels once the lava drains away. The Moon's volcanic past is well documented, and scientists posit these glassy structures could be lunar equivalents, their transparency stemming from superheated silica that cooled into a glass-like sheen. Probes like Japan's Selene mission have even detected gravitational anomalies suggesting vast, empty caverns beneath the Moon's surface, lending credence to the lava tube theory. But here's the wrinkle: the most famous of these tunnels, like the ones near the Marius Hills, exhibit a geometric precision that feels almost engineered. Their walls are unnervingly uniform, their curves too perfect, as if molded rather than eroded. This is where the controversy ignites. Independent researchers analyzing high-resolution images point to features that don't align with natural formation. Some tunnels appear to intersect at near-perfect right angles, their junctions too crisp for the chaotic collapse typically seen in lava tubes. Others show what look like reinforcing arches, structural flourishes that serve no clear geologic purpose, but mirror the design principles of human-made tunnels. Even more puzzling are the sections where the glass seems unnaturally clear, with sunlight passing through as if the material were polished. Volcanic glass exists, but it's usually riddled with impurities and fractures, not pristine enough to create these cathedral-like passageways. Then there's the scale. Some of these tunnels stretch for dozens of miles without a single collapse or irregularity, a feat of preservation that strains the limits of probability. On Earth, lava tubes rarely exceed a few hundred feet before crumbling. The Moon's lower gravity might explain some of this resilience, but even then, the tunnel's flawless preservation over billions of years feels like a cosmic fluke. Some theorists speculate they could be the remnants of an ancient lunar infrastructure, perhaps shelters or transport channels built by a long-vanished civilization. Others propose their natural formations altered by advanced technology, their surfaces deliberately smoothed for purposes we can't yet fathom. Skeptics, of course, dismiss these ideas as overreach. They argue that the Moon's lack of erosion allows structures to remain intact in ways that seem artificial to human eyes. Wind and water don't wear down features there, so even the most mundane formations can appear sculpted. Yet even the staunchest critics admit the glass tunnels are peculiar. No earthly lava tube gleams so brightly or stretches so far without interruption. And if they're truly natural, why do they cluster in specific regions, almost like nodes in some vast subterranean network? The glass tunnels linger in that tantalizing space between geology and mystery. They challenge us to reconsider not just the Moon's volcanic history, but the very definitions of natural and artificial. Until we send probes or rovers to crawl through their luminous corridors, they'll remain one of the Moon's most mesmerizing riddles, a labyrinth of light, waiting for someone to trace its path to the truth. One of the Moon's most elusive and debated anomalies isn't a structure, a flash, or even a temperature spike. It's something far stranger, a wave, not of water, of course, but of light. Imagine a luminous ripple gliding silently across the lunar surface, as if an invisible hand had brushed against a cosmic curtain. This phenomenon, dubbed the lunar wave, was captured in footage from NASA's Clementine mission in the 1990s, showing what appears to be a slow-moving band of brightness traversing the Moon's face like a spectral tide. The official explanation: data artifacts, glitches in the imaging system caused by cosmic radiation or sensor malfunctions, but those who have studied the footage frame by frame aren't so quick to dismiss it. The wave moves with eerie consistency, maintaining its shape and speed across vast stretches of terrain, something random interference simply doesn't do. What makes the lunar wave so compelling is its uncanny resemblance to atmospheric phenomena we see on Earth, like the way sunlight dances across water, or the shimmer of heat haze on a desert horizon. Except the Moon has no atmosphere, no air, no weather, no medium to bend or scatter light in such a deliberate way, yet the Clementine footage shows this luminous band sweeping over craters and plains alike, its edges sharply defined, its motion unnervingly smooth. Independent analysts who have enhanced the images note that the wave's leading edge casts subtle shadows, as if it's physically displacing something on the surface. Others point out that it aligns with known magnetic anomalies, regions where the Moon's crust holds pockets of unusual magnetism. Could there be a connection? Mainstream science remains skeptical, attributing the wave to pixel bleed, a technical flaw where bright pixels, smear, across adjacent dark areas in low-resolution images. But here's the hitch: Clementine's cameras weren't low-resolution for their time, and other glitches in the same dataset don't exhibit this kind of structured movement. Even more puzzling, similar waves have been spotted in modern lunar orbiter footage, always in the same general regions, always following the same inexplicable trajectory. If it's a glitch, why does it repeat with such eerie precision? The theories veer into speculative territory. Some researchers propose the wave could be evidence of electrostatic dust levitation, a process where charged lunar dust particles rise and move en masse under sunlight. The Moon's surface is known to harbor electric fields, especially near terminator lines where day meets night, but while this might explain diffuse glowing patches, it doesn't account for the wave's crisp, coherent form. Others suggest it might be a visual echo of subsurface activity, seismic waves from moonquakes briefly disturbing the regolith in ways that reflect light differently. Yet the Moon's quakes are rare and localized, while the wave spans hundreds of miles without breaking stride. Then there's the fringe hypothesis that we're seeing something far beyond conventional physics. Could the wave be an artifact of cloaking technology, a ripple in some advanced energy field, or even a projection from an unseen source? It's a stretch, but the very fact that such ideas surface speaks to how deeply the lunar wave unsettles our assumptions. In a place where every shadow, every rock, every crater has been mapped and measured, here's something that slips through the cracks of our understanding: a fleeting, luminous enigma that refuses to be explained away. Whether a trick of the light, a quirk of technology, or something genuinely unexplainable, the lunar wave lingers as a reminder that even in the age of high-resolution orbiters and AI analysis, the Moon still holds moments of pure mystery. And until we catch it in the act with modern instruments, or finally pin down its cause, it'll keep drifting across the edges of our perception, a silent, shimmering question mark written in light. In the desolate expanse of Sinus Medii, a region aptly named the Central Bay, for its position at the Moon's dead center, an anomaly looms literally. Towering above the flat, dusty plains is a structure that defies both logic and geology: the black spire, captured in high-resolution orbiter imagery. This razor-thin shadow stretches impossibly long across the lunar surface, a stark black line etched against the gray like a crack in reality. Calculations based on the angle of sunlight suggest the object casting it would have to be over a mile high, a skyscraper of stone standing in perfect, solitary defiance of the Moon's otherwise eroded, cratered landscape. And here's the catch: nothing in nature creates spires like this. Geologists have scrambled for explanations. On Earth, such slender pinnacles might form through millennia of wind and water erosion, like the famous rock towers of Cappadocia. But the Moon has no atmosphere, no weathering forces to carve delicate shapes. Volcanic activity could theoretically leave behind basalt columns, but those tend to cluster in hexagonal formations, not solitary needles. Even the most violent meteor strikes don't produce mile-high splinters of rock. Impacts shatter and scatter, leaving debris fields, not precision-cut monoliths. The spire's shadow reveals another oddity: it doesn't taper like natural formations. The edges are razor-straight, as if the structure were machined rather than fractured. Then there's the matter of material. The spire's surface appears darker than its surroundings, absorbing sunlight almost hungrily. Spectral analysis hints at an unusually high concentration of titanium or other refractory metal substances known for their strength and heat resistance. Could this be a natural outcrop of rare minerals? Possibly, but the spire's isolation is telling. Most lunar geological features exist in context: lava flows near old volcanic sites, debris around impact craters. The black spire stands alone, a silent sentinel with no apparent connection to the terrain around it. Theories range from the pragmatic to the provocative. Some researchers propose it's the remnant of an ancient volcanic dike, a vein of magma that solidified underground before being exposed by eons of micrometeorite bombardment. Others point to electrostatic forces, suggesting charged lunar dust might have accumulated into a fragile, towering structure over billions of years. But these explanations strain under scrutiny. Volcanic dikes rarely reach such heights without collapsing, and electrostatic dust would lack the structural integrity to maintain such a slender form. Then, of course, there are the whispers of artifice, the spire's proportions, its height-to-width ratio mirror modern engineering principles used in Earth's tallest skyscrapers to prevent buckling. Its shadow's crisp geometry has drawn comparisons to the obelisks of ancient civilizations, though on a scale dwarfing anything humans have ever built. Could it be a relic of some long-lost lunar culture, or even a marker left by extraterrestrial visitors? Without physical inspection, it's impossible to say. But the spire's very existence challenges our understanding of the Moon as a geologically static world. For now, the black spire remains a paradox, a shadow without a clear source, a structure without a clear origin. It's a reminder that even in the most meticulously mapped corners of the Moon, there are still features that refuse to fit our models, and until a rover or astronaut stands beneath its towering form, it will keep casting its long, enigmatic shadow, not just across Sinus Medii, but across our certainty about what's possible on the world above us. The Moon's surface is often described as a frozen record of cosmic violence, its craters standing as permanent scars from billions of years of meteorite impacts. But what if some of those scars simply vanished? Over the decades, astronomers and lunar researchers have documented a handful of cases where craters appear to disappear between missions, either shrinking dramatically or vanishing entirely from one set of images to the next. Take the case of Lynn Crater, a small but distinct formation in the Mare Serenitatis Basin. Early lunar maps from the 19th century show it as a pronounced, bowl-shaped depression, yet by the time Apollo missions photographed the area in the 1960s, Lynn appeared flatter, almost smoothed over. Skeptics dismissed it as a mapping error, but the discrepancy kept resurfacing literally. Modern orbiters like LRO have since confirmed the crater's altered appearance, reigniting the debate: how does a crater just fade away? Theories abound, each more intriguing than the last. One leading explanation points to moonquake seismic tremors caused by tidal forces from Earth's gravity. Though the Moon lacks tectonic plates, its crust still flexes and fractures, potentially triggering landslides that could partially fill in smaller craters over time. Others propose a process called impact gardening, where constant micrometeorite bombardment slowly churns the lunar soil, redistributing debris and erasing subtle features. But here's the problem: these processes operate on geological timescales, not the decades between observations. For a crater to visibly change within a human lifetime would require something far more dramatic. Then there's the imaging argument. Early telescopes and spacecraft had limited resolution, potentially exaggerating crater depth through shadow play. What looked like a deep pit in grainy photos might have been a shallow depression all along, yet this doesn't explain cases like the missing crater near the Mare Crisium Basin, where two separate Soviet orbiters, Luna 19 and Luna 24, photographed the same area just years apart, with the latter showing a previously documented crater completely absent. The odds of a camera glitch or lighting trick replicating the exact same error in the same location are slim. Perhaps the most provocative theory involves volatile substances beneath the lunar surface. Some researchers speculate that pockets of trapped gas or water ice, when heated by sunlight, could sublimate and destabilize the overlying regolith, causing sudden collapses. There's precedent. NASA LCROSS mission confirmed water ice in permanently shadowed craters, and if similar deposits existed near the surface elsewhere, they might explain rapid terrain changes. But even this falls short of accounting for the sheer speed of some disappearances, like the alleged vanishing of a small crater in the Apollo 15 orbital imagery, which astronauts swore was there during training simulations months earlier. The unsettling truth is that no single explanation fits all the cases. Some vanishings might be camera artifacts, others seismic flukes, and a few could hint at processes we've yet to discover. What's undeniable is that the Moon's surface isn't as static as we once thought. It's a dynamic, if subtle, landscape where even the most permanent-looking features might be hiding their own expiration dates. And until we establish permanent monitoring, or catch a crater in the act of disappearing, these gaps in our understanding will linger, reminding us that even the closest celestial body still has a few tricks up its sleeve. Among the Moon's most fleeting and mesmerizing tricks are the so-called lunar X and V transient shapes that appear near the terminator, the line dividing day from night, as if sketched by an unseen hand. These formations, visible only for a few hours each month, materialize with eerie precision, a crisp, angular X and a sharp, pointed V, glowing against the shadows like celestial graffiti. At first glance, they seem deliberate, almost like symbols etched into the landscape, but here's the twist: they're not structures, not carvings, not even permanent features. They're tricks of light and terrain, yet their consistency and timing raise questions that go beyond simple optics. The lunar X, perhaps the most striking of the two, emerges near the crater Werner when sunlight grazes the rims of several smaller craters at just the right angle. The intersecting ridges catch the light, creating the illusion of a glowing X suspended in the darkness. Similarly, the lunar V forms nearby when the illuminated edges of two ridges and a crater align to mimic the shape of a chevron. Both phenomena rely on the Moon's low-angle sunlight, which stretches shadows and highlights subtle contours in ways that don't occur under Earth's diffuse atmosphere. Skeptics argue this is all there is to it, a quirk of perspective, no different from seeing faces in clouds, but the precision of these shapes, appearing in the same locations with clockwork regularity, makes them feel oddly intentional. Timing is everything. The X and V only appear during a narrow window, typically within a few hours of the Moon's first quarter phase. This predictability has led some to wonder, could ancient observers have used these formations as lunar calendars? The shape's brief visibility and consistent positioning align with lunar cycles in ways that would have been invaluable to early astronomers tracking time. There's no direct evidence linking them to ancient rituals or navigation, but the possibility lingers like an unspoken footnote in humanity's relationship with the Moon. Then there's the psychological dimension. The human brain is wired to seek patterns, especially ones that resemble familiar symbols or letters. This phenomenon, called pareidolia, explains why we see constellations in random stars or faces in rock formations. Yet the lunar X and V stand apart because they're not random. They're reproducible, their formation governed by precise geometric alignments. This blurring of chance and design makes them uniquely compelling. They're not quite illusions, not quite artifacts, but something in between, a reminder that even the Moon's most explained anomalies can still stir wonder. What's most fascinating, though, is how these transient shapes challenge our assumptions about the Moon's personality. We think of it as a silent, unchanging orb, but the X and V reveal a world of fleeting drama, where light and shadow stage brief performances before vanishing into the dark. They're proof that even in a place we've mapped down to the meter, there's room for ephemeral magic, a reminder that sometimes the most extraordinary mysteries aren't about what's there, but what we're lucky enough to witness before it's gone. Among the Moon's many scientific puzzles, few are as confounding or as overlooked as its bizarre magnetic fingerprints. Unlike Earth with its planet-wide magnetic shield, the Moon's magnetism is patchy, inconsistent, and downright mysterious. Certain regions like Reiner Gamma with its luminous swirls generate magnetic fields far stronger than the surrounding terrain, while other areas show almost no magnetism at all. The strangest part, these magnetic hotspots don't line up with any known geological features. Craters, lava plains, and mountain ranges show no clear correlation to where these fields appear, leaving scientists scratching their heads over what could possibly be causing them. Theories point to two wildly different possibilities, one rooted in cosmic violence, the other dancing on the edge of speculation. The mainstream explanation involves ancient asteroid impacts. Around 4 billion years ago, the Moon was pummeled by a barrage of colossal space rocks, some so massive they could have vaporized chunks of the lunar crust. Computer simulations suggest these impacts might have hurled molten, iron-rich material into space, which then rained back down and cooled rapidly in the presence of the young Moon's now vanished magnetic field. This could have created localized fossil magnetism, frozen into the rock like a snapshot of primordial chaos. Supporters of this idea point to the magnetic anomalies around the Moon's giant basins, like Mare Imbrium, as potential smoking guns. But there's a problem: not all magnetic hotspots align with major impact sites. Some sit in seemingly random locations, their strength defying the gradual decay expected over billions of years. This has led to a more provocative theory that the Moon's crust might contain concentrated deposits of exotic materials we've yet to identify, or worse, that these anomalies aren't natural at all. A handful of researchers, often working outside traditional institutions, note that some of the strongest magnetic patches coincide with structural anomalies like the Shard and the Tycho Pyramid. Could these be remnants of some ancient, technology-laden infrastructure, their metallic skeletons still generating faint magnetic fields? It's a fringe idea, but the Moon's refusal to follow conventional magnetic models keeps the door ajar for unconventional thinking. Then there's the timing. Some studies suggest the Moon's magnetic field wasn't just weak in the past, it might have flickered on and off like a faulty light switch. Samples brought back by Apollo missions contain minerals magnetized in ways that imply brief, intense magnetic pulses, as if the Moon experienced sporadic geomagnetic storms long after its core should have cooled. One explanation points to tidal forces from Earth, which could have periodically stirred the Moon's molten interior, generating short-lived fields. Another, more radical proposal suggests external influences, like close passes by other celestial bodies, might have juiced the Moon's magnetism temporarily. What makes these anomalies so compelling isn't just their defiance of explanation, but their potential to rewrite lunar history. If the impact theory holds, they're time capsules from an era of unimaginable violence, preserving secrets about the early solar system. If something more exotic is at work, they could hint at processes or even presences we've barely begun to consider, and until we land magnetometers in these zones or drill into their depths, they'll remain tantalizing riddles, whispering that the Moon's quiet surface might just be the cover of a far stranger story. Gassendi crater doesn't just glow at pulses. While most lunar transient phenomena flicker unpredictably, this sprawling, 10-kilometer wide crater near the Moon's northern edge has a rhythm all its own. Apollo 16 astronauts first documented the phenomenon during their orbital passes, reporting rhythmic flashes emanating from Gassendi's floor, not random bursts, but steady, timed illuminations like a cosmic heartbeat. What makes these lights so distinct isn't just their regularity, it's how they defy every conventional explanation for lunar luminosity. Unlike the erratic flashes of Aristarchus or the diffuse glows in Plato crater, Gassendi's pulses follow a discernible pattern. Observers have clocked them at intervals ranging from minutes to hours, with some sequences repeating over multiple lunar days. During the Apollo mission, crew members described the lights as strobing, a term that suggests something more mechanical than geologic. Even more peculiar, the pulses often cluster around Gassendi's central peaks, a jagged cluster of mountains rising from the crater's floor, as if the light were somehow tied to their structure. Scientists have thrown every plausible theory at Gassendi, only to watch each one crumble under scrutiny. The usual suspect radon gas doesn't fit because gas discharges don't produce rhythmic bursts. Meteorite impacts too sporadic, and the timing's all wrong. Some researchers propose piezoelectric effects, where stress on crystalline rocks generates electrical charges that could spark brief flares. The Moon's tidal flexing from Earth's gravity might provide the necessary pressure, but even that doesn't fully explain the precision of the pulses. Then there's the magnetism angle. Gassendi sits on the edge of a magnetic anomaly, and some speculate that solar wind particles, funneled by invisible magnetic fields, could be exciting surface materials in a repeating cycle. But here's where the mystery deepens. Historical records reveal that Gassendi's pulses aren't a modern discovery. 18th century astronomers like Jean-Dominique Cassini noted periodic gleams in the crater long before the Apollo missions or modern imaging. This continuity across centuries suggests something fundamental and persistent is at work. Could it be an undocumented form of lunar quake, where shifting crust generates light through triboluminescence, or might the crater's unique mineral composition, rich in reflective or phosphorescent elements, be reacting to some cyclical stimulus we've yet to identify? The most tantalizing clue lies in the pulse's selectivity. They don't occur everywhere in Gassendi, just specific zones, almost like designated stages for the light show. High-resolution scans reveal that these active areas correlate with fissures and fractures in the crater floor, hinting at subsurface pathways for energy or gas. Yet no probe has ever been sent to investigate up close, leaving us with orbital snapshots and tantalizing gaps in data. Gassendi's lights stand apart from other lunar anomalies because they refuse to be ignored or dismissed as one-off oddities. They're a metronome in the silence, a signal in the static, and until we land a rover on those central peaks or deploy seismometers to listen for their source, they'll keep pulsing, a luminous enigma ticking away the seconds until someone finally deciphers their code. Deep beneath the Moon's silent surface, something pulses not with light this time but with motion. Scientists call them moonquakes, and unlike their earthly counterparts, these tremors follow rhythms so precise, they've earned a haunting nickname, the Moon's heartbeat. The Apollo missions first detected these seismic whispers in the 1970s, when astronauts planted sensitive instruments that recorded something unexpected. Every 27 days, like clockwork, the Moon shivered, not random spasms but timed vibrations, as if something vast and hidden were drawing breath. The strangest part, these quakes aren't shallow, skittering along the surface like impact tremors. They originate hundreds of miles down, near the Moon's core, where temperatures and pressures should render it geologically dead. Yet the data doesn't lie. The quakes arrive in predictable waves, aligning eerily with the Moon's orbital cycle around Earth. This timing has led to the leading, and most poetic theory, tidal forces. Just as Earth's gravity tugs on our oceans, creating tides, it might also flex the Moon's rigid crust, generating friction deep inside. Imagine gripping a rubber ball and squeezing it rhythmically. The Moon, in this analogy, is that ball, its interior straining under Earth's relentless pull. But here's where the mystery deepens. If tidal forces were the sole culprit, the quakes should be uniform, fading as the Moon's orbit shifts over millennia. Instead, they cluster in specific zones, like the aptly named hot spots near the edges of lunar Maria. Even weirder, some moonquakes register higher on the Richter scale than others, with magnitudes suggesting movements far more violent than tidal stretching should allow. This has sparked wilder theories, from residual magma sloshing in hidden chambers to the collapse of ancient underground caverns. A few researchers even speculate about cold quakes, where the Moon's shrinking core, cooling after billions of years, cracks like an ice cube dropped into warm water. Then there's the outlier, the so-called thermal quakes. These occur not deep underground but at the surface, striking with the abruptness of a gunshot just after lunar sunrise. The leading explanation, the moon's crust frozen at night, expands so rapidly under the sun's sudden glare that it fractures audibly. It's a reminder that even in the vacuum of space, temperature swings can be brutal -270 degrees Fahrenheit at night, soaring to 250 during the day. But even this doesn't account for all the seismic oddities. Some thermal quakes seem to echo, their vibrations lingering longer than physics predicts, as if the moon's interior were hollow in places, a notion that, while fringe, refuses to die. What makes the moon's heartbeat so unnerving isn't just its regularity, but what it implies about our cosmic companion, a world we thought inert, a relic of cosmic collisions, might still be alive in ways we don't yet grasp. Every pulse, every tremor is a cipher, one that future missions, armed with modern seismometers, might finally decode. Until then, the moon's vibrations remain a silent drumbeat, a reminder that even in the stillness of space, nothing is ever truly at rest. Deep within the moon's far side, shielded from Earth's radio chatter, lies a crater that shouldn't be making noise, and yet it is. Tsiolkovsky crater, a sprawling impact site named after the father of astronautics, has been emitting radio waves in patterns that defy everything we know about lunar silence. The first hints of this anomaly came from Soviet probes in the 1960s, which picked up erratic bursts of electromagnetic static near the crater's central peaks, not the usual cosmic background hiss, but structured, almost rhythmic pulses. Decades later, NASA Lunar Prospector mission confirmed it. Something in Tsiolkovsky was broadcasting, and no one could explain why. The strangest detail. The signals cluster around a specific frequency range between 1 and 2 MHz, a band that overlaps with natural planetary emissions, but also, coincidentally, with early human radio technology. This overlap sparked immediate intrigue. Could these be echoes of some long-lost Soviet or American equipment? Unlikely. The signals persist even in areas no mission has ever touched. Geologists point to the crater's unique composition as a potential culprit. Tsiolkovsky's floor is rich in anorthosite, a reflective mineral that dominates the moon's highlands, but it's also laced with ilmenite, an iron-titanium oxide known for its conductive properties. When sunlight hits these deposits, they might act like natural antennas, converting solar energy into radio noise, yet even this explanation falls short. The signals don't correlate neatly with lunar day or night cycles, and their sporadic bursts suggest something more dynamic than passive mineral reactions. Some researchers propose piezoelectric effects, the same phenomenon behind quartz watches where stress from tidal forces generates electrical discharges in crystalline rocks. Others speculate about hidden volatiles, pockets of trapped gas or water ice sublimating under temperature shifts, creating electrostatic disturbances. But neither theory fully accounts for the signal's peculiar regularity, which occasionally mirrors mathematical sequences found in natural resonance patterns. Then there's the wild card, magnetism. Tsiolkovsky sits near one of the moon's most pronounced magnetic anomalies, a region where the crust behaves like a local force field, deflecting solar wind. Could these magnetic fields be interacting with charged particles or mineral deposits to produce the radio waves? It's a compelling idea, except for one glaring inconsistency: the anomaly's magnetic strength fluctuates, while the radio emissions don't always follow suit. The most tantalizing possibility, that we're hearing the moon's version of a natural radio station, a phenomenon entirely new to science. On Earth, we have Whistler's radio waves generated by lightning, traveling along magnetic field lines. Could Tsiolkovsky's emissions be the lunar equivalent, sparked by some unseen process we've yet to imagine? Until we land a rover in that crater, armed with spectrum analyzers and ground-penetrating radar, the truth will remain encrypted in those enigmatic waves. For now, they pulse in the dark, a cosmic transmission waiting for someone to tune in and listen. Among the moon's most polarizing anomalies are the so-called lunar fossils, blurry, enigmatic shapes in orbital imagery that some researchers insist resemble ancient organic remains. Take the infamous lunar skull photographed near the Jules Verne crater, a formation with hollowed-out depressions eerily reminiscent of eye sockets and a nasal cavity, its jagged outline tracing what looks like a half-buried cranium. Or the dragon bone fragment spotted in Apollo 15 imagery, a twisted, segmented structure jutting from the regolith like a petrified spine. To true believers, these aren't just tricks of light, they're potential relics of a biosphere that once thrived in the moon's forgotten past. But here's the catch: the moon has no atmosphere, no liquid water, and no known mechanisms to preserve organic material, so how could fossils even exist there? Mainstream science dismisses these claims as textbook pareidolia, the brain's tendency to impose familiar shapes on random patterns. After all, humans have spotted faces in clouds, animals in rock formations, and even religious figures in burnt toast. The lunar surface, with its chaotic terrain and harsh lighting, is a prime canvas for such illusions. Skeptics point to the skull's jagged edges, arguing they're textbook examples of fractured bedrock, while the dragon bone is likely a twisted lava formation, its segmented appearance caused by thermal cracking as it cooled. Even the shadows conspire to deceive. Low-angle sunlight can stretch and warp perceptions, turning mundane ridges into haunting silhouettes, yet the fossil debate takes a curious turn when you examine the outliers. Some formations display textures that defy simple geology, like the honeycomb patches near the Mare Ingenii basin, where the surface appears pockmarked with hexagonal cells resembling fossilized coral or insect nests. High-resolution scans reveal these aren't impact craters, their walls are too smooth, their depths too uniform. Planetary geologists propose they could be gas escape vents or collapsed lava tubes, but the precision of the hexagons nags at the edges of plausibility. Even more provocative are the strand-like anomalies in certain crater walls, thin, fibrous structures that, when enhanced, resemble fossilized root systems or microbial mats. This is where the radical hypotheses ignite. A small but vocal cadre of researchers, like the late astrobiologist Gilbert Levin, argued that the moon might not always have been the sterile wasteland we see today. Billions of years ago, during a hypothesized wet moon phase, volcanic outgassing could have created temporary atmospheres and even shallow bodies of water environments where primitive life might have briefly gained a foothold. If true, the fossil-like structures could be the shattered remnants of organisms that adapted to these fleeting oases, their remains preserved in vacuum-sealed stasis. It's a fringe idea, but not without precedent. Scientists recently revived ancient bacteria from Earth's harshest environments, proving life can endure extremes we once thought impossible. The counterarguments are fierce. Without erosion or sedimentation, the moon lacks the processes that fossilize organisms on Earth. Even if life existed, critics argue, solar radiation and micrometeorite bombardment would have pulverized any organic material beyond recognition within millennia. Then there's the contamination question. Could these fossils be discarded equipment fragments or even degraded insulation from old missions, their materials warped by decades of exposure to lunar conditions? Apollo-era artifacts litter the surface, and some bear uncanny resemblances to the very formations cited as evidence. What makes the fossil controversy so compelling isn't just the imagery, but what it reveals about our own biases. We're pattern-seeking creatures, desperate to find familiarity in the alien. Every blurry photo becomes a Rorschach test, proof of life to some, proof of pareidolia to others. And until we retrieve these objects, or until a rover rolls up to that skull and confirms it's just another rock, the controversy will endure. The moon, as always, refuses to surrender its secrets easily. It dangles just enough ambiguity to keep us questioning, toying with the line between discovery and delusion, and perhaps that's the real lesson here. In the silent vastness above us, the most enduring mysteries aren't just about what we see, but what we're desperate to believe. Among the Moon's most radical mysteries is the idea that it isn't solid at all, that beneath its cratered exterior lies an immense, echoing void. Known as the hollow moon theory, this fringe hypothesis gained traction in the 1960s when Apollo seismometers recorded something bizarre. After lunar module impacts, the Moon reverberated like a bell for far longer than expected. When the Apollo 12 crew intentionally crashed their ascent stage into the surface, vibrations lasted over an hour, an unnaturally sustained resonance compared to Earth's tectonically dampened tremors. Coupled with the Moon's unusually low density, just 60% that of Earth's, despite its rocky composition, some researchers began asking the forbidden question: what if our satellite isn't what it seems? Proponents of the hollow moon point to other anomalies, like the uneven distribution of mass beneath its surface. Regions called maskins, mass concentrations exert stronger gravitational pulls, yet their density variations don't align neatly with known geology. Then there's the Moon's precise orbit, which defies celestial mechanics. Its size, distance, and speed relative to Earth create a perfect eclipse, a statistical improbability if it formed naturally from debris. Could these quirks hint at an artificial origin? Some theorists, like Soviet scientists Mikhail Vasin and Alexander Shcherbakov, speculated the Moon might be a hollowed-out vessel, engineered by an advanced civilization and placed in orbit as an observatory or even a generational ship. Mainstream science, unsurprisingly, dismisses these claims. Geophysicists argue the prolonged seismic waves stem from the Moon's dry, rigid structure without water or atmosphere to absorb shocks. Vibrations propagate freely. The low density, a relic of its violent birth, when a Mars-sized object collided with early Earth, the ejected debris that formed the Moon may have been lighter materials from the outer layers. As for maskins, they're likely remnants of ancient asteroid impacts that left dense metallic cores embedded in the crust, and eclipses, a temporary cosmic coincidence. Tidal forces are gradually pushing the Moon away, meaning perfect alignments won't last forever. Yet the hollow moon theory endures, fueled by unresolved oddities. Why do some craters appear shallower than their impacts should allow, as if hitting a reinforced shell? Why did Apollo astronauts report metallic reverberations during moonwalks, describing the surface as ringing under their boots? Even Carl Sagan entertained the possibility of hollow celestial bodies in his 1966 book Intelligent Life in the Universe, though he cautioned against unsupported leaps. The debate ultimately hinges on what we're willing to consider and what we dismiss as fantasy. While Occam's razor favors natural explanations, the Moon's stubborn refusal to fit all our models leaves room for wonder. Until we drill deeper, or map its interior with precision, the hollow moon will linger in the realm of tantalizing what-ifs, a reminder that even our closest neighbor might still harbor secrets waiting to shake the foundations of what we think we know. Among the most tantalizing and deliberately obscured lunar mysteries are the images captured by the Soviet Union's Luna program in the 1960s and 70s. While NASA Apollo missions dominate public memory of lunar exploration, the USSR's unmanned orbiters quietly documented something far stranger: clusters of geometric shapes scattered across the Moon's surface, some so precise they resemble the skeletal outlines of massive structures. For decades, these photos languished in classified archives, dismissed as optical noise or camera glitches until they weren't. The most infamous of these images came from Luna 9, the first spacecraft to achieve a soft landing on the Moon in 1966. As it panned its cameras across the ocean of storms, the grainy black and white footage revealed a series of angular, grid-like formations rising from the dust. Unlike the random scatter of boulders or crater debris, these shapes featured intersecting lines and right angles, some arranged in concentric rings. Soviet scientists reportedly debated their origin in hushed meetings, with a faction arguing they were artifacts of the imaging system, while others whispered about non-natural configurations. The debate might have stayed buried if not for Luna 13, which 2 years later photographed similar anomalies near the crater Kepler, a collection of what looked like stacked slabs or terrace platforms, their edges unnervingly straight against the chaotic lunar backdrop. Declassification only deepened the intrigue. When the Soviet Union collapsed in the 1990s, a trove of lunar data was released to international researchers, but with glaring omissions. Key frames from the Luna missions were missing, and surviving images bore cryptic redaction marks. Independent analysts who enhanced the available photos noted something unsettling. The geometric patterns weren't just surface level. Shadows cast by the structures suggested depth, as if they were the exposed tips of larger, buried complexes. One set of images, allegedly from a later Luna mission, showed a cluster of pyramidal mounds near the lunar terminator, their symmetry matching no known volcanic or impact formations. The official explanations remain unsatisfying. Soviet archives attribute the anomalies to compression artifacts or solar glare, but these don't account for the consistency of the shapes across multiple missions and lighting conditions. Modern lunar orbiters like NASA LRO have since photographed the same regions, yet the images released to the public lack the resolution needed to confirm or debunk the Soviet findings. Conspiracy theorists naturally smell a cover-up, a coordinated effort by space agencies to suppress evidence of extraterrestrial ruins. More measured voices propose an intermediate possibility, that the structures are natural formations warped by pareidolia, but that their unusual regularity warranted enough concern to pull them from public view. What makes the Luna photos uniquely compelling is their timing. They emerged during the Cold War's peak, when space exploration was as much about propaganda as science. If the Soviets had found incontrovertible proof of non-human structures, why not trumpet it as an ideological victory? The fact that they didn't, that these images were buried instead, suggests something more nuanced than a simple alien base. Perhaps the truth lies in the shadows of those geometric shapes, not quite natural, not quite artificial, but something in between, a lunar riddle still waiting for its Rosetta Stone. Until the archives open wider, or new missions revisit these sites with modern tools, the Soviet photos will linger as ghostly snapshots of a mystery we're not yet meant to solve. Even as we push further into the age of high-resolution lunar mapping, the Moon refuses to surrender its mysteries, proving that advanced technology doesn't always bring clarity. Sometimes it just sharpens the questions. Modern orbiters like NASA Lunar Reconnaissance Orbiter and India's Chandrayaan missions have delivered stunning, centimeter-level imagery of the surface, yet their data is peppered with anomalies that defy simple explanations. Take the case of the impossible shadows, captured by LRO in 2012 near the crater Tycho. The orbiter's cameras documented slender, kilometer-long streaks of darkness stretching across the terrain shadows, with no visible object to cast them. At first, scientists assumed these were artifacts of the imaging process, perhaps glitches caused by sunlight bouncing off the spacecraft itself, but when the same shadows reappeared in subsequent passes, always in the same locations, that theory crumbled. These weren't camera tricks, they were real, persistent features with no discernible source, as if something invisible were blocking the light. Then there are the reflections. Chandrayaan-2's high-resolution terrain mapping camera has repeatedly recorded glints of light in areas where none should exist, pinpricks of brilliance flashing from the depths of permanently shadowed craters near the lunar poles. These aren't the diffuse glows of outgassing or meteorite strikes, they're sharp mirror-like flashes, lasting only seconds before vanishing. The Indian Space Research Organization initially attributed them to solar wind interacting with microscopic ice crystals, but here's the twist: some of these flashes occur in craters where no water ice has ever been detected. Even stranger, a handful of the reflections seem to follow predictable paths, reappearing at specific times of the lunar day, almost like celestial lighthouses cycling on a hidden timer. Perhaps the most confounding modern anomaly is the disappearing craters phenomenon. Elrose before and after imagery of certain regions, like the Mare Ingenii Basin, reveals small impact craters that simply vanish between orbital passes, not eroded or filled in, but gone without a trace. One leading hypothesis suggests these could be sinkholes collapsing into subterranean lava tubes, yet when LRO's Diviner instrument scanned these sites, it detected no temperature variations typical of fresh collapses or exposed cavities. It's as if the surface simply healed itself. What ties these modern oddities together is their defiance of legacy models. The moon, we're learning, isn't just a static museum of ancient impacts. It's a dynamic, if subtle, world where light, shadow, and geology interact in ways we're only beginning to glimpse, and with every pixel of new data, we're confronted with the humbling truth: some lunar secrets aren't hidden in the past. They're unfolding right now in real time, waiting for us to decode their riddles. From towering spires to pulsing craters, vanishing formations to eerie light shows, these 25 lunar anomalies aren't just curiosities, they're cosmic breadcrumbs, each one leading us deeper into the labyrinth of what we don't know about our closest celestial neighbor. The moon, long dismissed as a dead rock, keeps proving it's anything but ordinary. These mysteries force us to confront uncomfortable gaps in our science. How can a crater vanish in decades? Why do magnetic fields cluster like invisible cities? What's casting shadows with no visible source? Every answer we think we have unravels into 3 new questions, and that's the thrill of it. For every skeptic shouting, pareidolia, there's a baffled geologist staring at data that refuses to fit the models. The shard, the Tycho pyramid, the Blair Cuspids structures so precise they flirt with the idea of design. The lunar swirls, those glowing brushstrokes defying magnetism's rules, the hollow moon theory, seismic echoes ringing like a bell in a vacuum, even the solved anomalies like the lunar X whisper subtler riddles about light and perception. This isn't about proving aliens or ancient civilizations, it's about recognizing that the universe is stranger than our textbooks dare admit. So where do we go from here? The best part of these mysteries is that they're yours to explore. Dig into the Apollo archives, where raw footage hides clues in grainy corners. Track fresh data from missions like Artemis or China's Chang landers. Debate the Soviet Luna photos or the latest LRO findings with fellow night sky detectives. The moon isn't done surprising us, and neither are the people studying it. Every amateur astronomer, every armchair theorist, every kid with a telescope adds another set of eyes to the search. Stay skeptical, but stay open. The day we stop questioning the moon's secrets is the day we stop learning. So keep looking up, keep questioning, and most of all, keep wondering, because out there in the silence between the shadows and the light, the next great discovery is waiting. And who knows, maybe you'll be the one to finally connect the dots. The cosmos loves a curious mind. Let's keep giving it